Hello, Year 11s. Hope you're continuing to keep well. I'd like to try some live lessons this week, but we have a lot of early morning lessons, it looks like. So I think that we should try a live lesson on Wednesday, because that one's in the afternoon. If you could comment on the Google Classroom, that'd be really, really helpful to let me know what your thoughts are on that. Yeah. All right. We're nearing the end of trigonometry. We are going to look at finding the area of a non-right angled triangle today. I found this question online somewhere, no idea where. It is a quadrilateral, but if you cut it in half using a diagonal, you can turn it into two triangles. So I would like you to attempt to find the distance from B to C. Now, this is a 6-mark question, so you should take at least 6 minutes to answer it. If you can do it quicker than that, then great. I'm going to go ahead and pause the video now, and then I'll work out the solution. And when we all get back, you can see the answer, okay? All right, there is a lot going on in this question. Chances are, I could have made a mistake. So if you got a different answer than me, please do let me know. It doesn't always mean that I am correct. So the first thing that I did was I drew the green line from B to D, and I used the cosine rule to find out how long is the length from B to D. And then after that, I did the working out in red. I used, again, triangle ABD to find out angle X, and I used the sine rule for that. So I used the 14.5 that I got in the first part and the 150 with the side 8 to find that little angle X in there. And then from there, I could use triangle BCD to actually work out the length of BC using the cosine rule again. Okay, hopefully I didn't make too many mistakes in that one. I think that's kind of a cool question. I think you're probably looking at roughly 2 marks for each of those different colored workings out. And yeah, I don't know, I thought that was a pretty great question. I would definitely say that's more of a grade 8 or 9 kind of question, but yeah. All right, let's get started for today. So today's lesson can be either really simple or it can be really complicated. Just to know the area of a triangle formula for non-right angle triangles is a bit fancy. They used to give it to you in the front of the exam paper, but they don't do that anymore, and they don't give it to you at A level either. So just knowing that, I would say is grade 7. Using that is probably also grade 7. Using it when you have to find a missing side or angle instead of the area, probably grade 8. And then we also can do some challenge questions where we have algebra or exact trig values in them. I've tried to find some of those, so hopefully those give you a nice challenge. All right, so the formula for finding the area of a non-right angled triangle is 1/2 times by side A, times by side B, times by the sine of angle C. Now, the only rules about this, it doesn't always have to be A, B, and C, but it's actually going to look similar to the cosine rule, as in we're always going to have two sides. So for instance, A and B, and then we always have to use the angle that's between them. Okay, so 1/2 AB sine C, and we just multiply everything together. We just have to remember that it's the two sides and the angles between and the angle between it. All right, let's put this into a little bit of practice. Maybe you drew that in your book, maybe you didn't. I'm not really sure. All right, so example 1, calculate the area of the triangle, correct to 3 significant figures. I don't know the height of this triangle. I don't really want to try to find the height of the triangle, so I'm going to use what I know about trigonometry. I know the two sides and the angle in between them, so I can use my sine rule for finding the area of a triangle. So I've got area equals a, oops, sorry, I messed that up already. 1/2 times by a times by b times by the sine of the angle between them. All right, and popping that into my calculator, I get 23.606. So to 3 significant figures, 1, 2, 3, the 0 does nothing to that 6, so 23.6 centimeters squared. All right, and that is pretty much the extent of what I'm asking you to do today. I'm going to get you to do the next question by yourself, and then I'll give you the answer after that. So exact same kind of idea, just a different triangle. Go ahead and try to calculate the area of this triangle, correct to 3 significant figures. I'll come back with the answer in just a moment. All right, here is the answer I got for this example. Hopefully I didn't make too many silly mistakes in this one. Yeah, 15.0 meters squared. Let's try another one. Okay, so example 2 this time, slightly different. We're going to change it up a little bit. This time they would like us to calculate the length of side A. So they told us the area, and they have two sides and the angle in between them. So we're just going to have to substitute and rearrange. So we know that the area is equal to 1/2 AB sine C. So let's go ahead and substitute in what we know. So the area is 25. 1/2 times by A times by B times by the sine of 131. Now you can reorganize this however you want. I'm going to try to do it in 2 steps to show you what I want to do. First thing I'm going to do is times by the 2 to get rid of the half. So I end up with 50 is equal to A times by 17 times by the sine of 131. And then I'm going to go ahead and divide both sides by all of the 17 times the sine of 131. So 50 divided by 17 sine of 131 should be equal to side A. Okay, you don't necessarily have to do as many steps as I just did. You can probably do less than that. I just want to show what I was actually doing in this question. So popping this into my calculator, me and my calculator are not getting along. I end up with an answer of side A is equal to 3.897, so maybe 3.9. Okay, so ever so slightly different, you just need to rearrange. I'm going to get you to try one of those questions by yourself now, or you can just skip ahead to the next example. I really want to tell you it's different, but yeah, go ahead and try example 2 here. Calculate the length of side B. Pretty much exactly the same as what I was just saying. I'm going to go ahead and pause the video, and then the answer will pop up. All right, so when rounding to one decimal place, I ended up with 7.4 centimeters. Hopefully I haven't made too many errors there, and let's move on and try something fancier, I think. All right, example 3, we can rearrange not for just one of the side lengths, we can also rearrange for the angle. Calculate the size of angle X. So thankfully we have two sides and we are interested in the angle between them. So we go ahead and we start to, I'm just going to write down what we know. We know that area is equal to 1/2 AB sine C. Sine C is just going to be sine X, and A and B are going to be 8 and 9. So 30, which is the area, is 1/2 times by 8 times by 9 times by the sine of X. So if I go ahead and start to rearrange that, again, I'm going to do this in steps so I can show you what I'm doing. Multiply everything by 2. I end up with 60 is equal to 72 times by the sine of X. So 60 divided by 72 is going to give me the sine of X. So if I want to find X, I can take the inverse of both sides and I end up with the sine inverse of 60 divided by 72. And then I pop that into my calculator, sine inverse 60 divided by 72, and I get 56.4 degrees. Okay, I can't remember if I have an example for you to try now. Let me pause and check. I don't. We're going to move on to something fancier. I think you kind of get the idea of these kinds of things. So let's look at some more fancy questions. All right, I feel like I'm about to get really excited about a question because I feel like this is a really, really great question. So we're suddenly bringing back some circles as well. We would like to attempt to find the area of the shaded segment of this circle. We need to give our answer to 3 significant figures. So what I'm thinking is we find what would have been the area of this entire piece here. So we find the sector of the circle. We can do that. Hopefully we remember how to do that. And then we use our area of this blue triangle in here to help us figure out what that blue area is, and then take it away from the whole sector, and we'll just be left with the purple part. Now you might be thinking, Miss Strangers, they've only given us one side and one angle. Fear not. This 5 centimeters is a radius, which means that this side over here is also 5 centimeters. So I'm going to start by first trying to find the area of the segment. Let's see if I can get a purple pen as well. Okay, I found a purple pen. Here we go. So we're looking for the area of the sector. So that is theta divided by 360 times by pi times by r squared. So that is the area of a circle times by the fraction of the circle that we have. So the area of the sector is going to be 120 divided by 360 times by pi times by 5 squared. So that is 1/3 times by 25 pi, which is not going to look super nice. So I'm just going to leave it as 25 by 3 times by pi. We'll get to the decimals at the end. Then we're looking to find the area of the triangle. So area of the triangle is going to be 1/2 times by 5 times by 5 times by the sine of 120. So I'm going to grab my calculator, 25 times by 1/2 times by the sine of 120. And I'm going to, see, it doesn't look very nice either. We're just going to go with 10.8. We'll go with a few more decimal places, 2.5. So there's the area of the triangle, and we have the area of the sector. So if we want to find just the shaded area, we're going to subtract those two things. So the shaded bit is 25 divided by 3 times by pi, which we'll put into a decimal, minus 10.825. 25 by 3 times by pi, oops, can't use my calculator, and then minus off 10.825, we get 15.355, and to three significant figures, 15.4 centimeters squared. All right, there is our final answer. I really like that question. I know I get way too excited about some of these things, but yeah, I thought that was pretty cool. Example 5 is also a pretty fancy question as well. I would say example 5 is definitely going to be a grade 9 question. So let's get ready for that. Here is another one that's similar to the last one if you'd like to try it by yourself. It's got a few more things happening on it. It's got 3 sides actually, not just 2, because remember, these are the radius. So both of those are going to give us 5 centimeters. So if you want to work this one out, I think you can definitely do it. They didn't give us the angle, but they did give us all 3 sides of the triangle. So maybe press pause now, and I will come back with an answer as well. Okay, this was quite a long question. I tried to color code things, so hopefully that does help. I started out by finding the angle x using the cosine rule. I didn't show all of my steps. I should have also shown 14 divided by negative 50 and then the cosine inverse of that, but I was really panicked about how much room I was going to have. After that, I found the area of the entire sector using the angle that I had first found. So that angle times by, or divided by 360 times by pi r squared, and I found that area. And then I looked at finding the area of the actual triangle using my formula from today, and then the area of the segment by subtracting them. All right, last example from me is going to be a nice one with, I think, some exact trig values in it. So this is an old school exam style question. I just really like it, and I think it is something that they would bring back. And it's, again, something that they like to use in A-level as well. We love a good old show that question. So the diagram shows the triangle PQR. P to Q is X, and P to R is 2X. Angle QPR is 30 degrees, and we need to, it says the area of the whole thing is actually a centimeter squared. We need to show that length x is actually equal to the square root of 2a. All right, here we go. Let's start filling in what we know about the area. So we know that area is equal to 1/2 AB sine C, and we know that the area is A, and then we've got 1/2 times one of the sides, which we can call x, and then we've got the other side, which is 2x, and then we've got the sine of 30 degrees. Now, hopefully you remember that the sine of 30 degrees is actually the same as a half, or 0.5, however you'd like to remember that. So if we go ahead and multiply these things together, we end up with a is equal to 1/2 times by 2, which gives us 1, and x times by x, which is going to give us x squared. So this whole first part here is just going to give us x squared times by a half. How shall we write that? Let's write times by a half like that. All right, so now we're trying to get all of this just having x all by itself. So I'm going to multiply both sides by 2. So I end up with 2a is equal to x squared. And if I want to get x by itself, I can take the square root. So x is equal to the square root of 2a. Isn't that beautiful? It's just a nice little 3-mark question. As you can see, once you get started on it, it's actually not that fancy, but I do think it's a bit scary and daunting when you first look at it because you're thinking, I just want to put this in my calculator. All right, I think that is us done for today. I'm going to try to get you a variety of questions. You don't have to do all of them. If you're feeling really confident with just finding the area, move on and try the more complicated ones. I'll try to split it into 3 different tasks, if not maybe 4 different tasks, okay? Let me know if you have any questions. Bye.